Can you hear me?
Comms check. This is Roche Orbital, broadcasting from an unknown solar system in the Formidine Rift. This part of the Milky Way has less stars, but there are still plenty of stellar bodies out here just waiting for us in the darkness. Today we found an exoplanet orbiting a massive main sequence star. It's not alone out here though. There are several gas giants in the system to accompany it. It seems to have Earth-like properties. From lower orbit, I can see what looks like water and large green landmasses. Well, I'd like to talk about exoplanets in this broadcast, in honor of this beautiful specimen that we found. The term exoplanet simply means a stellar body that is outside of our Sol system. But this term always got me excited when I was a kid and still does even today. Earth alone has so much to experience and learn about. But pondering other planets with different chemical makeups on the surface, strange atmospheres, and possibly life is just thrilling to me. Over the years, astronomers have concluded that Sol is quite rare when compared to other star systems. The majority of star systems that can be seen have similar traits with one another. One or two gas giants that orbit very far away from their home star, and a very massive exoplanet that orbits close to that star. These exoplanets are usually so close to their home star that the chance of life is next to zero, as the rocky surface is literally being cooked, and the atmosphere gets obliterated by solar winds. These types of systems are the most common found through the eye of telescopes. The reason for this is from the formation of the system at the very beginning. As gravity starts to pull all the cold gas in an interstellar medium together, this gas heats up and starts fusing atoms in nuclear fusion. This process eventually births a star, which becomes the main gravity well for everything else near it. The leftover gas starts to rotate around this baby star and slowly forms a gas giant, which wasn't quite big enough to become a star. The rock and dust in this early solar system gets pulled into orbit around the home star, and over millions of years, it becomes a planet. So understanding the general process of interstellar solar systems helps me truly appreciate how lucky we are to live in Sol, and stand in awe at the stunning planetarium we have access to. So, from this, we can draw that complex solar systems are not very common. But this does not mean they don't exist. In fact, the closest star system to Sol has unique properties, and it's only 4 light years away. We have arrived at Alpha Centauri. This is actually a 3-star system. Alpha Centauri A and Alpha Centauri B are similar to our Sun in mass, and they orbit each other. The third star's name is Proxima Centauri, and it orbits the other two. While the 2 stars in the center are main sequence stars similar to Sol, Proxima Centauri is a red dwarf. All stars are categorized on the main sequence chart according to their relative temperature, and red dwarfs are in the class of M and have a surface temperature around 6,000 degrees Fahrenheit. This also means they are far dimmer than other stars and shoot less energy into the surrounding medium. So, the Goldilocks zone would change for a planet orbiting a red dwarf. What's the Goldilocks zone, you might be asking yourself? It's the habitable zone for life to exist on a planet while orbiting a host star. For example, the Earth is in the Goldilocks zone of Sol. If we were too close to the Sun, then we would end up like Mercury, a scorched rock. And if we were too far away, we would end up like Pluto, a cold and lifeless stellar body. Surprisingly, Proxima Centauri has 3 exoplanets orbiting it, and one lives in the Goldilocks zone. Its name is Proxima Centauri B. Proxima B is just over Earth's mass at about 1.3 times, which is promising. Liquid water could exist on Proxima B if other properties are met, such as an atmosphere, magnetosphere, and the right chemical makeup on the surface. With all these characteristics present, chance and a lot of time could produce life. But as of now, we only know Proxima B at face value. But the existence of life on its surface remains a possibility and is quite exciting for me to ponder. The Alpha Centauri system is 4 light years away from us, so to get there traveling at the speed of light, it would only take 4 years. But as of today, humans do not have this technology. We need to collectively put our heads together and find a way to bend gravity to our benefit. This requires a lot of energy and for now remains a theoretical idea. Roche Orbital's hyperdrive has back-engineered Forerunner tech, which allows us to bend space-time to our will. This is not yet open source technology, so we're very blessed to travel through space with no restrictions. But there is still much to be discovered using other methods than space travel. A great example of this is the Transiting Exoplanet Survey Satellite, or TESS. TESS launched on a SpaceX Falcon 9 rocket in April of 2018 with the goal of mapping hemispheres of space and logging exoplanets within them. It is a joint effort with MIT and NASA at the helm and many other members lending their expertise. The goal is to better understand how many other planets are out there waiting to be seen. TESS monitors stars over a long period and looks for small drops in brightness that are consistent. This shows the astronomers that there is a planet in the star system. The small blip in brightness is a planet passing between the star and TESS. In its 2-year mission, TESS confirmed 66 exoplanets orbiting stars and logged another 2,100 potential candidates for astronomers to confirm with more observations. TESS went above and beyond its initial goal and finished its 2-year mission. But just because TESS finished its first goal doesn't mean it will be decommissioned. MIT and NASA plan to keep TESS operational until 2028. In fact, the first exoplanet TESS found was named TOI 700D, and it is about 100 light years away from Sol. TOI orbits a red dwarf star similar to Proxima Centauri B, and orbits within the star's Goldilocks zone. Although TOI is far away, it still feels like a blessing that we discovered it and have the ability to learn a little bit about its home system. TOI could be a planet covered in volcanoes that reach up to the heavens, or a water world with waves the size of mountains. Maybe a life form is there, enjoying a dim red sunset on the surface, gazing up into the night sky in our direction, wondering if anyone else is out there in the void. On behalf of Roche Orbital's crew, I'd like to thank you for listening, and I hope we piqued your curiosity today. Seeing your life as an interconnected part of the universe is called a cosmic perspective. To grasp how small you are in this grand play we call our universe is important. Although we may be small in size, we are all connected to one another, and we are all connected to the cosmos around us. Hopefully one day we stop seeing other people as just them and see everybody as one. This is Roche Orbital, signing out. Late.